Welcome to the Tobacco Online Policy Seminar. Thank you for joining us today. I'm Zihan Ren, a consumer science PhD candidate at The Ohio State University. TOPS is organized by Mike Pesco at the University of Missouri, Xishan at The Ohio State University, Michael Darden at Johns Hopkins University, Jeremy Herman Boyce at the University of Massachusetts Amherst, and Justin White at Boston University. The seminar will be 1 hour with questions from the moderator and discussant. The audience may pose questions and comments in the Q&A panel, and the moderator will draw from these questions and comments in conversation with the presenter. Please review the guidelines on tobaccopolicy.org for acceptable questions. Please keep the questions professional and related to the research being discussed. Questions that meet the seminar series guidelines will be shared with the presenter afterwards, even if they are not read aloud. Your questions are very much appreciated. This presentation is being video recorded and will be made available along with presentation slides on the TOPS website, tobaccopolicy.org. I will turn the presentation over to today's moderator, Xishan from the Ohio State University, to introduce our speaker.
Thank you, Zihan. Today, we conclude our winter 2026 season with a single paper presentation by Erin Eidschun entitled Burning Questions, Dual Dynamics of U.S. Cigarette and E-cigarette Demand. This presentation was selected via a competitive review process by submission through the TOPS website. Erin Eidschun is a PhD candidate in economics at Boston University. Her research utilizes structural modeling to analyze demand and supply dynamics in the U.S. nicotine market, with a specific focus on the mechanisms of habit formation. In particular, she studies consumer switching behavior between cigarettes, e-cigarettes, and abstaining from smoking. She received an MA in economics from the University of Chicago in 2020 and a BA in economics from the University of Chicago in 2019. Erin, thank you for presenting for us today.
Thank you for having me. I'm going to go ahead and share my slides. Okay. So I'll be presenting my research today here. It's called Burning Questions, Dual Dynamics of U.S. Cigarette and E-cigarette Demand. I do have to go through some disclosures. So first off, I have received no funding for this paper or any other tobacco-related funding in the past 10 years. And also I do use Nielsen data, but the research here and my conclusions are my own and not, they do not reflect the views of Nielsen at all. So I'll start off with some motivation here. So in the adult market in the US, the cigarette smoking rate is 11.6%, according to the CDC in 2022. This is down to 6% for the e-cigarette adult smoking rate instead. Now, how do these two rates or smokers interact? So it turns out, according to the 2015 CPS tobacco use supplement, that 35% of cigarette smokers who attempted to quit in the previous 12 months used e-cigarettes as a cessation aid. This number went down to 25% in 2019. So what this brings to question is what effects may exist and which dominate? That e-cigarettes function as a cessation aid for traditional cigarette use, or that they may actually function as a gateway effect to cigarette use. As for example, maybe someone will develop a high preference for nicotine or high craving, or develop some sort of relaxed attitude about smoking in general. So this is really important to consider, given that cigarette and e-cigarette policies are simultaneously in place and sometimes not necessarily coordinated. For example, if e-cigarettes do function as a cessation aid for cigarettes, then e-cigarettes should be regulated with that in mind, perhaps not actually being so stringent on the regulation. A lot of existing work has touched on this, but it focuses on cross-sectional substitution. For example, with using excise tax variation in cigarettes to see the impact on both cigarette and e-cigarette use. I instead want to look at choices at the individual level, and I want to do that via a structural model. The benefit of a structural model in this context is that I can incorporate counterfactual approaches that you cannot do in a reduced form setting. So this brings me to my research question, which is how does smoking history drive at the individual level transitions between cigarettes, e-cigarettes, and abstinence? I will implement a counterfactual in which I ban e-cigarettes and I show how this ban impacts choices of cigarette use, e-cigarette or no e-cigarette use, and abstinence. The method that I use is a nested logit, in which I study consumer adoption and switching between cigarettes, e-cigarettes, and abstaining, and I emphasize past smoking behavior. I develop an original model of nicotine addiction as part of this model, and I also develop a new method of addressing price endogeneity in this literature. I put these two in red because these are the primary contributions of my research. I'll be brief about the literature review. So there's a little bit of structural work in the area, these three papers here, but most of it is at the cross section or doing reduced form, showing, for example, negative relationships between smoking and the regulation, or showing that cigarettes and e-cigarettes may be substitute goods. Some relevant background I'll introduce here. So I will be discussing some state and federal regulations of cigarettes and e-cigarettes. So these regulations, again, can be specific to cigarettes or e-cigarettes. So you might have a regulation on cigarettes, but not e-cigarettes and vice versa at the same time within a state. So the first one I want to go over is prohibiting the self-service display of cigarettes or e-cigarettes. This is what prevents you from simply walking into a store and grabbing a cigarette or e-cigarette off the shelf. You tend to maybe have to talk to someone behind a counter or ask them to unlock a box for you. There's also minimum age of purchase laws, smoke-free air laws, also known as SFA laws, which prohibit you from smoking in public spaces indoors. And then finally, requiring retail licenses to sell. So many states, for example, will require a vendor to pay an application fee and fill out an application in order to sell year to year. Finally, there are excise taxes. So for e-cigarettes, there's been a lot of variation in this over the years because this is a newly regulated product. Cody et al. Estimate a pass-through that's pretty high, between 0.9 and 1.01 of excise taxes on e-cigarettes. For cigarettes, there's a lot less variation, but there still is variation in the last few decades, again with a high pass-through rate of 1 to 1.10. Just to give you an idea visually of how the four laws that I described before have evolved for e-cigarettes, this is a graph showing the time period that I will be studying, 2013 to 2023. On the y-axis, I have the number of states in DC, so the maximum level in this figure is 51, and it shows the number of states or DC that have implemented these laws over the time period in question. So there's a lot of variation. The figure for cigarettes is basically flat during this period with just a little bit of variation. So I'm going to move to my model now. So I study this using a panel nested logit. And the reason I have to use a panel model is because I'm interested in switching behavior at the individual level, and so I need repeated observations of them. So each month M, some agent I who lives in US state S chooses some alternative J in their choice set. Their choice set is three choices: a representative cigarette, a representative e-cigarette, or abstaining from smoking. They do this in consideration of several factors, one being e-cigarette smoking laws, cigarette smoking laws, and these refer to the four that I was just talking about: price, their demographics, and their smoking history. And I put this in bold because this is kind of what I want to focus on in my model. So smoking history consists of switching costs, adoption costs, and this new term that I've coined, nicotine stock. And I choose a nested structure to relax the IIA assumption. And so you can think of it as a consumer, when choosing their choice for the period, they choose to smoke or not to smoke. If they choose not to smoke, they enter this degenerate nest where there's just one alternative, not smoking. And if they choose to smoke, then they choose between cigarettes and e-cigarettes. I will point out that when I say smoking, by the way, in this presentation, I'm referring to smoking of cigarettes or e-cigarettes, just so there's no confusion. So to go over this past smoking behavior, I'm going to start with switching costs. So I define four switching costs. One is from cigarettes to e-cigarettes, e-cigarettes to cigarettes, cigarettes to not smoking, and e-cigarettes to not smoking. So these should be treated as product characteristics. And what that means is every single period, when a consumer sits down and they look at their three possible choices, they kind of assign a switching cost of 1 or 0 to each alternative. And then they choose based on that, amongst, as well as demographics and other things that I will cover. So the switching cost, each of the switching costs is a binary variable. It's equal to 1 if the choice from the prior period is not equal to the alternative being considered this period. So if I smoked cigarettes last period and I look at my choice set, if I see cigarettes this period, I will see I would incur a switching cost of 0. If I see e-cigarettes for this period, I would incur a switching cost of 1. And then finally, if I choose not to smoke or if I consider not smoking, I also realize I would incur a cost of 1. You'll notice that I haven't done the kind of last two directions, which is going from not smoking to cigarettes or not smoking to e-cigarettes. And that's because I prefer to actually code them as what I call adoption costs. And so there are two adoption costs. One is a cigarette adoption cost. It's also binary, equal to 1 if you have smoked cigarettes in any of the prior 2 periods, and 0 otherwise. And the analogous is for the e-cigarette adoption cost. Finally, for the smoking history variables, I bring you nicotine stock. So this is not meant to reflect how much nicotine is kind of like left in your body because that does dissipate really quickly over time, I believe in 24 to 48 hours. It is more a measure of the level of your addiction. So what is nicotine stock? The data that I will end up using allows for detection of exactly how much nicotine is contained in the cigarette or e-cigarettes purchased by these agents. And that's based on seeing the e-liquid capacity and strength, as well as cigarette type. So with this data, I can actually convert this to some sort of approximate nicotine yield in the product. And I can also, you know, use what's called a transfer efficiency to estimate how much of the product's nicotine enters the body. This transfer efficiency is just based on some medical literature I have found, and I do realize that to properly measure how much nicotine is entering the body, you have to do scientific studies, but this is kind of the best we can do in the literature given the number of individuals. So an example of how nicotine stock is calculated, I will first talk about how to first calculate nicotine yield. So suppose that there is a e-cigarette product that is 30 milligrams per milliliter in strength. It contains 2 milliliters of e-liquid. The person has purchased 2 units of this, and there's a 0.68 transfer efficiency assigned to e-cigarettes. This will result in an 81.6 milligram nicotine yield for that purchase. And so I'll draw your attention to the first equation here, that large N subscript IJM. This resembles a capital stock accumulation equation in the macroeconomics literature. And the idea is that every single period, you can invest in your nicotine stock with this small n, which is that nicotine yield from your purchases. And at the same time, your prior nicotine stock will be degrading at this rate delta. And delta is specific to the alternative. So for no smoking, there is never any nicotine in that alternative. So the nicotine stock for that will always be 0. For cigarettes and e-cigarettes, they can degrade at different rates. What goes into the nested logit equation eventually is in blue here, that N subscript IM, which is a sum over the alternative cigarette and e-cigarette of their nicotine stocks. And finally, we assume that the nicotine stock in the first period starts at 0. With all this in mind, I can show you the full nested logit form. So again, each period in M, an agent I located in state S derives a utility U from purchasing alternative J in their choice set. Their utility consists of an observed and unobserved component. The observed component is what I have walked you through here so far. It includes prices, a vector of switching costs, laws that are specific to cigarettes, and laws that are specific to e-cigarettes. So there are 4 for each. The nicotine stock of the agent, a vector of household demographics, the 2 adoption costs, 1 for cigarette and 1 for e-cigarettes, and finally fixed effects, which are at the alternative, state, and year level. So you'll notice that price is in red here, and that's because the equation as it's written here features an endogenous variable price. And I do want to address this, so I'll go into that in the next few slides. So I first want to cover what is the issue with addressing price endogeneity in a nonlinear framework. Standard methods such as 2SLS are actually only appropriate for linear settings. And the reason for that is because the second stage in 2SLS, if applied in a nonlinear framework, will mangle the errors, and you will get a biased result. So this is not an option here. I propose this instead, which is first, I estimate that same nested logit model from the previous slide. but I add market time level fixed effects. These are meant to capture like the mean utility at that market time level. And so what drops out due to the variation, the level of variation of the fixed effect is laws, prices, product fixed effects, state fixed effects, and year fixed effects. Now, this is not very simple to implement, in fact. So my data is a size such that I'm actually adding 18,000 fixed effects at once. And so doing the log likelihood optimization is not very straightforward anymore using, for example, stata's nlogit command. And even coding this manually from scratch, the log likelihood function, you'll not be able to overcome computational issues because it's very hard to find the optimum. So instead, I use a minorization maximization technique from Chen et al., and I derive a version that is appropriate for the nested logit model. And how it works is basically it creates a surrogate function that is much easier to optimize, but has the same optimum as the log likelihood function. So after this step, what I have are these estimated fixed effects, and I regress these on product characteristics and instrumented price, where price is instrumented in an equation that looks very much like a first stage of a 2SLS, which is appropriate. The first stage is fine to use. And I use excise taxes as the instrument. This has been used widely in the literature in the reduced form. And I see an F test of 33.4. So I'm not very worried about a weak instrument problem. Finally, I construct standard errors via a bootstrap method with 500 simulations. Now, I will mention that the other approach that may be appropriate here at first glance would be the control function approach that has been used in the literature for nonlinear endogeneity. But the assumption that I would need to make in this setting is that unobserved price shocks and unobserved utility shocks are linearly related, otherwise known as bivariate normality. My approach instead has a less strong assumption, which is that all unobserved market time level heterogeneity, such as local trends or advertising, are captured by the market time level fixed effects. Now, to bring this to the data, so as I've mentioned, I'm using Nielsen data, and the goal here is to build a monthly panel of purchases at the agent level from 2013 to 2023. I started at 2013 due to sufficiency in the data on e-cigarette purchases. My main data source is the Nielsen consumer panel data. And what this is it's a data source that surveys 40 to 60,000 households annually. It's not a balanced panel. And it surveys household purchases and demographics. And so what happens is households that participate are given a scanning device. And when they make purchases, they're expected to scan the barcode of their purchases into the panel, and that gets registered in the Nielsen data. They're supposed to report their price and the place of purchase as well as demographics. Nielsen does actually put in their own prices where they can, so it's a little bit more accurate reporting. And what I do is I only take households that smoke sufficiently frequently in the data. So those are households defined as having 4 or more purchase transactions while they're observed in the data. Finally, I aggregate that to the monthly level where the choice that they make, cigarette, e-cigarette, or nothing, is defined by the majority of their monthly expenditure for cigarettes and e-cigarettes. So, of course, no one is spending the majority of their money per month on cigarettes or e-cigarettes. But when I'm deciding between cigarettes and e-cigarettes, if I observe both purchases, I choose based on the majority. This is not really an issue about dual usage because I find that less than 1% of households actually split their spending between just 15 and 85% for cigarettes and e-cigarettes. I supplement this with Nielsen retail scanner data in order to construct prices. It also provides nicotine strength, which is used to construct that nicotine stock variable. And these are all used to get my sales weighted representative cigarettes and e-cigarettes, which I'll discuss next. I also have some data on e-cigarette e-liquid capacity and nicotine strength from Coddy et al. And some manual collection. And then from the CDC, I take state smoking laws and excise taxes on cigarettes. For excise taxes on e-cigarettes, Coddy's paper has actually standardized these for e-cigarettes at the milliliter level. So the choice is at the state and month level. So how exactly am I going to calculate or construct some sort of representative e-cigarette or cigarette? This is especially interesting for e-cigarettes because, as we know, they come in all different shapes and sizes and strengths. And so my method here is in order to aggregate weekly Nielsen retail data to the month and state level is I take as representative price the average price per milliliter at that month and state level, and I multiply that by the average e-liquid capacity at that month and state level, where averages are constructed using e-liquid sales weights. And so the benefit here is I'm just able to see how much e-liquid is sold every month and state. And so that is how I can get some sort of homogeneous or representative e-cigarette. I apply this formula for the excise tax instrument as well. For representative cigarettes, it's a lot more straightforward because they come in like standardized sizes and they come in packs or cartons. So it's much more straightforward to do sales weighted representative cigarettes. At this point, I'll pause for questions.
Thank you, Erin. Our discussant today is Dr. David Levy, a professor of oncology in the School of Medicine at Georgetown University. So, David, do you have any comments at this point? Thank you.
Well, just superb methodology, very well presented. It was a pleasure listening, and just a couple of very minor points. Um, I notice you're doing a multi-equation approach, but one of the papers that you didn't mention, the single equation approach, there's several papers by Abigail Friedman. And I think it'll be very interesting for you to compare your results to hers. And, one of the aspects I think she does very well is she really looks she's done a lot of study of the policies, and it seems like, and I'm not sure, but it seems like there's some more policies that she includes for e-cigarettes. So again, you might want to take a look at her paper. That's the only comments I have.
Okay, well, I will do. Thank you so much for the reference.
Thank you. There is one audience question from Samuel Asar. Do you consider dual use of e-cigarettes and cigarettes in your modeling?
Right. So this is what I was trying to get at with the 1% statistic that I oopsies quoted. So when I look at aggregation of my data to the monthly level, I was concerned first about dual usage, but I don't find in this data that people are really dual using based on their expenditure split between cigarettes and e-cigarettes. Only less than 1% of households end up splitting their expenditures between like a 15-85 split or 85-15 split. So I'm not very worried about it, and I do not consider it. You're only able to buy one product per period. If you mean dual usage by, I buy cigarettes this period and e-cigarettes next period, then that is completely allowed.
But this is sort of in conflict with some of the prevalence data, nationally representative surveys showing that dual use is quite prevalent, especially among adult users. So have you checked, whether it is because of the difference in the nature of data or
It could be due to the difference in the nature of data. Unfortunately, this, to my knowledge, is the only panel data set where I can observe the quantity of nicotine consumed as well. And so that might just be a caveat of using the Nielsen data, unfortunately.
Thank you. I don't see any other questions coming up, so please continue. Thank you, Erin.
Okay. Okay, so I will move on to some summary statistics. So the types of households here are pretty heavy smokers. So if you look at the percentage columns, the rightmost three columns, for all three household types that I'm showing here, which are split by households that only ever smoke cigarettes their entire time in the data, only ever smoke e-cigarettes their entire time in the data, or have some sort of transition between one or the other, you'll see that the percentage of time they're smoking is really, really heavy. So for cigarette only, that's almost 50%. For e-cigarette only, that's nearly 40%. And for those that smoke cigarettes and e-cigarettes, that's about 44%. Another thing I will draw you to in this table is that there is a huge representation of cigarette-only households in this data, excuse me, relative to e-cigarette only households in the data. And finally, with these both or dual households in the data. So that is some other drawback of the Nielsen that I'm worried about not capturing e-cigarette use to the extent that is representative of the U.S. adult population. You can also see this in the transition matrix as well. So if you look at the top two rows in the rightmost column, you'll see that the transition to e-cigarettes is very low. And so what I'm hoping to actually say today is, this is a drawback of the data, the underrepresentation of e-cigarette purchases, but despite that low level of e-cigarette use in the data, I'm going to show you that I can still see some interesting results in my e-cigarette ban counterfactual, and I'm still able to model the purchases that I am seeing in the data. So I'll get to my estimates now from that large nested logit equation that I presented earlier. So the price estimate here is that where I've addressed the endogeneity issue. And so I do find a negative price coefficient. And then as I suspect, I find negative switching cost coefficients. I've converted the estimates, by the way, into the change in odds percentages for easier interpretability. As for my nested logit parameter, 0.624, it's between 0 and 1, and so this lends some support that the nested logit model was an appropriate choice. And then for the depreciation rates on cigarettes and e-cigarettes, these are about the same at 0.23 and 0.25, which are pretty low. And I suspected that these two would be kind of similar to each other because when you're addicted to nicotine, it doesn't really matter where the source is from. Nicotine is nicotine, and so I was quite happy that these turned out to be about the same. I have about 2.5 million observations, so that's the households times the number of periods that they're in the data. And moving to the estimates that are specific to cigarettes or the estimates that are specific to e-cigarettes, I just highlighted in blue the ones I would like to pay special attention to. So for this household nicotine stock, which I've scaled per 300 milligrams of nicotine, I find a large positive coefficient. And so this 30.5% that you can see in the change in odds percentage column for cigarette means that as a household consumes 300 milligrams more of nicotine, their probability of choosing cigarettes over nothing increases by 30.5%. For e-cigarettes, this is also quite similar, with that percentage being 29.9% increase in choosing e-cigarettes over not smoking. As I would expect, previous cigarette smoking is highly predictive of current cigarette smoking. So this variable smoked cigarette in the last 2 months, that's the adoption cost in cigarettes, is very large. And likewise for e-cigarettes, the smoking e-cigarettes in the last 2 months is highly predictive of smoking e-cigarettes this period. Now, what I call the cross adoption cost, so for example, smoking e-cigarettes in the last 2 months, that effect on cigarette choice, surprisingly, I don't find any effect here. And so I'm not really finding that gateway. And for the opposite, smoking cigarettes in the last 2 months, I don't find a significant effect on the proclivity to choose e-cigarettes today. So I'm also not finding a cessation effect here. But there can be some sort of story, perhaps, that actually increasing your nicotine stock through e-cigarettes may lead to cigarette use or vice versa. That is distinguished from these kind of adoption costs that I have laid out. So we'll move on to my simulations now. So there are two types of simulations I do. The first one is a model fit. And what I do is I take the data, I let all covariates evolve as they do in the data, except for this smoking history, because that gets to evolve endogenously. So switching costs, adoption costs, and nicotine stock, they evolve based on the simulated choices for each household in my data. For the baseline and the counterfactuals, what I do instead is I fix all covariates at values from the household's t=1 value, except for smoking history variables. I assume that there is zero smoking history, and so I zero out switching costs, nicotine stock, and adoption costs. And I'm interested to see how people end up smoking or not smoking over time, just purely based on these variables and not, for example, price changes or law changes. Once that's done, for both the model fit and the baseline and counterfactuals, I calculate choice probabilities, I simulate the next period's draw, and I repeat this over and over again, and I average out estimates across simulations. So this is how my model fit looks. So this is for a particular cohort in the Nielsen data, and it's not meant to actually represent how smoking actually evolved from 2018 plus 36 periods from 2018. But as you can see, the final values, which are plotted here, showing the actual versus simulated shares of cigarettes, e-cigarettes, and not smoking amongst the households in this cohort, are pretty spot on. So I'm quite happy with that. For the counterfactuals, I've done a number of counterfactuals where I've actually zeroed out adoption cost, separately zeroed out switching costs, and finally assigned nicotine stock to zero, which is equivalent to having no nicotine on the market at all in these cigarettes and e-cigarettes. I'm just going to show you the figure for the no adoption cost counterfactual for the sake of time. So you can see here, as I said, that no one starts with any smoking, and so those cigarette and e-cigarette shares in red and purple start at zero, and the no smoking share starts at one. And you can see that over time, they converge to this like long run steady state where the in the baseline, you see 64.2% of non-smokers, and for cigarettes, you see 34.8%. And finally, for e-cigarettes, it's the remainder. For the counterfactual, you can see that the trends change quite a bit. When you zero out adoption costs, you see that the no smoking share rises significantly. I will point out that this took about 10 years to converge. That's 120 periods. And I investigated this, and this is actually due to the low depreciation rate of the cigarette, which I found very interesting. That basically addiction is not, the nicotine stock addiction is not dwindling fast enough. And so it takes a very, very long time for convergence to be achieved. So for the other two counterfactuals that I mentioned, I've put all three of these into a table for you to see how the baseline shares change with those counterfactuals. So the baseline shares are 34.8%, 1.1%, and 64.2% for the cigarette, e-cigarette, and non-smoking share. And the change relative to that is what is shown in the three rows at the bottom. So the adoption costs I already showed. For the nicotine being zeroed out, there's a lesser effect on the non-smoking share than the adoption cost being zero. And finally, the switching cost being zero has the least effect on non-smoking share. The final counterfactual that I run, which I think is the most interesting, is an e-cigarette ban counterfactual. And so what I find with the e-cigarette ban counterfactual is that 65.3% of e-cigarette choices that were made in the baseline become non-smoking choices in the counterfactual. The remaining 34.7% of e-cigarette choices in the baseline become cigarettes in the counterfactual. I wanted to see how this could be decomposed because obviously just with the nested logit structure, there's going to be some positive change from e-cigarettes to cigarettes. And so I present a few findings here. The first is that banning e-cigarettes leads to a modest increase in cigarette smoking. So in black, I have my baseline density for the number of periods smoking cigarettes. You can see the median is 28.2 and the mean is 36.6. When e-cigarettes are banned, this red hashed density, the amount of time smoking cigarettes increases a little bit. But I was interested in how this actually might be decomposed even further. So it turns out that this actually disproportionately harms smokers that had very little smoking duration and those that had very high smoking durations. So if you look at this figure here, on the x-axis, I have the baseline smoking of cigarettes duration in months for these households. And on the y-axis, I have the counterfactual. So if the point is above the 45-degree line, that means that in the counterfactual, this household smoked for longer, cigarettes for longer. And you can see that in the blue and the red points, which are the bottom 10% and top 10% per deciles by the baseline smoking amount, most of these dots are above the dotted line. But in this green portion in the middle, there's a lot more heterogeneity here. So for some households actually smoke cigarettes less in the event of an e-cigarette ban. My next finding is that when e-cigarettes are banned, there are shorter abstinence durations. Now, abstinence here is defined as the length of a streak of no smoking within the simulation. So the graph on the left shows abstinent periods from abstaining from both cigarettes and e-cigarettes. So you can see from moving from the baseline to the counterfactual, those mean and medians do increase sorry, they do decrease, excuse me. And then on the right-hand side, just abstaining from cigarettes, you do see a lesser change here, but that there are shorter abstinence durations. My next finding is that banning e-cigarettes also leads to smoking cigarettes earlier, which my understanding from the medical literature is smoking cigarettes earlier is worse for your health than smoking cigarettes later. And so you can see that there's a small change here of about 1 month or 1.5 months in going from the baseline to the counterfactual. And so this brings me to the summary of my findings. So first, I don't find evidence of switching being driven by adoption costs. However, nicotine stock and switching costs may be capturing this instead. Adoption costs play the largest role in the choice to smoke, followed by nicotine levels, so nicotine being zeroed out, and finally switching costs in those counterfactuals. And then finally, with my e-cigarette ban, I find that this leads to an overall modest increase in cigarette smoking. However, there's some heterogeneity here, and there's some larger jumps in the bottom decile and the top decile. Secondly, I find that the ban leads to shorter abstinence durations from cigarettes and e-cigarettes, or abstinence defined by just abstinence from cigarettes. And finally, the ban leads to earlier cigarette initiation by about 1 month. I think what this means is it's important to think about targeted policy here because it's not quite clear um, whether or not banning e-cigarettes actually might be very, very good for the health of all of these adults in the market if you are willing to assume that e-cigarettes are less harmful for your health than cigarettes. And so I hope that policymakers do consider this moving forward. As for next steps for me, I'm hoping to incorporate some sort of reduced form into this. So perhaps some event study on excise taxes or something else. Maybe there's some sort of nicotine policy that can be exploited in the US. I'd also like to perform some sensitivity checks. So one of them is that this Nielsen uh, purchase data is at the household level. I do observe how many people are in the household, so I have thought about doing a sensitivity check in which I subset for single person households only. And then also one where I might change the length of months that defines the adoption cost for cigarettes and e-cigarettes. Finally, I thought about perhaps trying to capture the heterogeneity in the e-cigarette landscape, which has seen a lot of entry and exit over the time period, by incorporating a variable on the number of brands or products available. Thank you. That's my presentation.
Thank you, Erin. Audience, please submit your questions through Q&A. We look forward to hearing from you. Let's go to our discussion first. Dr. Levy, do you have any questions or comments? Thank you.
No questions. Again, great presentation. I do have a comment though. I think we'd all agree that e-cigarettes have been, continue to be a major shock to the whole nicotine use. As you alluded to, I think in the last slide, the nature of e-cigarettes changed over time, evolving to tanks and then to jewel-like disposables. What that suggests to me is potentially important is that the coefficients may not be stable over time. So I think it's important, particularly to check the stability of price, but yeah, maybe some of the other variables also. So that's it.
Right. That makes a lot of sense. I could maybe interact my price coefficient as well with some sort of time coefficient. But yeah, that'd be interesting. Thank you.
Thank you. I don't see any other audience questions, but I have a follow-up question. So as David just described, the e-cigarettes have evolved significantly, especially around like 2016 and 2017, when they like dual type of e-cigarette have has started to use different nicotine formation, right? So the nicotine salt for that's the term. So I think, just like a simple kind of sensitivity analysis looking at just like 2016 or 2017 as the cutoff to see
Mhm.
whether there are any changes. That would be very interesting. Yeah.
Yep, I agree. I think I've thought a lot about that time period in particular in my data because there was such a huge change to the industry. So thank you.
Yeah. I'm also curious about the important parameters you have in your structural model. I'm just wondering, like, can you describe a little further about what policies those parameters might be able to inform? For example, the stocks and the switching cost. For example, like, can you map them to like certain policies? Just
Sure.
out of curiosity. Thank you. Mm.
Sure. So I would say my hypothesis right now that I need to dig into more is that the switching that we're seeing from e-cigarettes to cigarettes, if not driven by the adoption, the cross-adoption costs, might be driven by that nicotine stock. So it's not shown here, but the marginal effect of nicotine stock on cigarettes is massive compared to that for e-cigarettes. And so my theory is that as people consume nicotine through e-cigarettes, that might make them more inclined to consume cigarettes, because they have this addiction to nicotine now that they, for some reason, want to fulfill with cigarettes. And so maybe the policy there would be to start regulating the amount of nicotine in e-cigarettes in the US instead, so that that nicotine stock cannot be built up as much. I mean, I don't know that you can exactly regulate how often someone can purchase an e-cigarette. It sounds like that would be more of like a prescription type model, which I don't think would really fly. So maybe the most realistic policy would be a nicotine limit on those e-cigarettes.
Yeah. Well, we have one audience question from David Keeley. So at this point in 2026, how do you go about factoring nicotine pouches in your research model, or does it not even fit as a confounder? So I guess this is getting into products that are not included in your two product dynamic model. So do you
Right.
have comments?
Yeah, so I did look into pouches and lozenges at some point, and I found that they were even less represented than e-cigarettes in the data, and so I've chosen to ignore them. But if I were to carry this study forward to that like 2024 or beyond, that is something I would reevaluate, because I do understand that's a large segment of the market at this point. I don't think I would feel comfortable with just allocating that to the non-smoking. Um, Unless I just purely just wanted to make statements about smoking products, vaporized products, for example. Yeah.
Yeah. Thank you. There is one question from Pasha Moghadam. Great presentation. Could you please say a bit about how e-cigarettes are captured in Nielsen data in your analysis? Which products, modules, UPC filters you used, and how you dealt with changes over time?
Yes, so Nielsen fortunately categorizes e-cigarettes themselves with a product module code 7467, if I remember correctly. But I did do manual checks of their assignment because I found that they were incorrectly assigning cannabis products as e-cigarettes on occasion. And I also found some e-cigarette brands that were not being captured. Either they were labeled as lozenges or something else. But I did a lot of manual work on that as well to make sure that I was capturing an accurate landscape of the e-cigarettes in the industry.
Yeah, thank you. There is a question from Samuel again. I know this might be out of scope, but e-cigarettes are mostly used by youth who don't use home scan machines. Probably they hide to purchase them or are not part of the household purchases. How do we generalize these results to heavy e-cigarette users, especially youth and young adults?
Right. So the Nielsen consumer panel data is mostly geared toward the adult market. So I'm not trying to make any statements about the youth market. What I would not be able to capture is if, for example, a parent is buying e-cigarettes for their child, which I hope is not very frequent, that they would do that and then scan that in as well. And I would doubt that, youth members of a household were wanting to kind of add to their parents' participation in this survey and scanning themselves. So I'm just simply making statements about the adult market only.
Thank you. Question from Norbert Schmidt. Have you considered that addiction or dependence is multifactorial and not exclusively based on nicotine?
I guess I would was trying to capture that with the switching costs and the adoption costs. Like I'm under the assumption that the consumer inertia is captured in the model fully by the three smoking history variables. But when we think of about addiction, the primary driver is nicotine. So that was where I was going with that.
Thank you. So I don't see any other questions. Oh, there's a question from Mike. Pascal, let's see. Cigarette retailer license requirement has a large positive effect on cigarette smoking. How should we think about this?
Yes, so that's something else I'm trying to unpack. I am wondering if this might be a simultaneity issue, actually, where states institute these licensure laws when they're trying to when demand is skyrocketing. Um, rather than seeing this effect being negative in the vein of, oh, the law is put in place and then people reduce smoking because there are less cigarettes on the market. Um, Perhaps this could be helped if I add some sort of measure of like retail density um, as well. So I'm not ready to make a conclusion yet about that because I'm trying to unpack that coefficient.
Thank you. I see David also wants to ask something. So David, do you want your camera on and make your questions or comments?
Yeah, yeah. Related to, I think Mike's comment, you're using retailer data, and I think that's about a third of the market, mass market retail. So I think it's important. It's hard to get data for, vape shops and for internet, but I think it's important to think about how those different sectors relate to each other.
Hmm. Yeah, I think I really tried unpacking this early in my research, and I looked into maybe like web scraping and things like this. But I don't know that I, I don't know how much progress I don't think I had made progress on that. But I do understand that the retail landscape of Nielsen is not fully representative um, of the market.
Yeah, I think one comment following on that is a lot of the products, at least at this point, may have been illegal because they don't have the FDA authorization and they may be shipped from overseas and just re very hard to capture those type of products that you wouldn't be able to scan it and know what type of brands, right?
So surprisingly, so that yes, there are a lot of illegal products on the market post 2018, but for some reason Nielsen still reports, or like the stores are actually still scanning them in, so that has not seemed to be an issue, thankfully. Um, but my understanding with the Nielsen retail data is that it's not that the store can actually decide. I talked to a Nielsen representative about this. The store cannot decide not to record. The price or quantity sold at their store unless they literally just want to do a cash transaction. So basically, if any barcode passes the scanner, that will be put into the Nielsen retail data. And so that's why we are seeing we're still seeing illegal products in the data, luckily. Luckily for the research, I mean.
Thank you for that info. I didn't know
Yeah.
that's the case. Another question from Mike. Have you looked at e-cigarette sales over time in home scan? And does that pattern you observe match patterns in adult use?
Matching I'm assuming you mean matching the like wider population, some more representative surveys of e-cigarette purchases. Um, For e-cigarettes, I'm using the Kilts version, which is a little bit less rich than the paid for Nielsen version. So I suspect no, that it's not a very good representation of like sales dollars over time. What I'm just kind of hoping is that while the e-cigarette transactions like frequency recorded by the households might be um, suppressed overall, that it's still sufficient for me to capture these, counterfactuals that I have implemented and things like that.
Thank you, Erin. I don't see any additional questions. Thank you for the presentation. Very good information. Thanks. So I'll turn it to our MC to take us out. Zihan, thank you.
Yeah, so we are out of time. If you are interested in presenting for us next season, please consider submitting a brief presentation proposal on our website, tobaccopolicy.org, by April 13th. Thank you to our presenter, moderator, and discussant. Finally, thank you to the audience of 150 people for your participation. Have a top-notch weekend